It's time for a bit of mechanics, a little bit of SHM. What have we got? We've got a boat. It is moored at harbour and it is moving up and down, up and down, and up and down, up and down, modelled as a particle in simple harmonic motion. We know it takes 2.5 seconds to go from the highest point to the lowest, and the highest and lowest points are 0.8 meters apart. There is 2 points. A is 0.1 meters below the highest point. B is 0.65 meters below the highest point. We want to find the speed of the boat as it passes through A, speed, importantly, not velocity, and the shortest time to go from A to B. Let's give ourselves a little sketch. Now, I am going to make my life a little bit easier, and I'm going to do this cosine style. So we're going to start at our highest point, something like that. Now, if we know the distance between the points is 0.8, that will be plus 0.4, that will be minus 0.4. And we also know that that point there is at 2.5, therefore that point there is at 5. So we know a few things. So my SHM, my height, is going to be some amplitude cos omega t. We are going to find A, we're going to find omega, and we're going to do it quite easily. A is simple. We're going from plus 0.4 to minus 0.4. That is 0.4 cos omega t. Okay? Now, when t is 2.5, right, cos h is minus 0.4. So what I need is I need 2.5 omega there has to equal to pi. Okay? Because I know that cos of pi is equal to minus 1. So 2.5 omega is pi. Omega is 2 pi over 5. Probably the easiest way to write it. Okay? So we now know the formula for this bad boy. 0.4 cos 2 pi over 5t. That is how we're modelling this. Now, we could have a little shift in there where it doesn't start at the highest point, but we don't really care about that right now. So what we want is we need to know the point A, which is here. All right, and that is 0.1 meters. So that is actually at 0.3 height. And point B is 0.65 underneath it. So point B will be somewhere there at minus 0.25, because then that's 0.65. Now we're going to use our fancy pants thing for simple harmonic motion, which is the fact that v squared is a squared minus omega squared x squared. Okay? Or in our case here, I suppose, h squared. Okay? Fairly nice and chill, simple harmonic motion. So we want to know what's going on at 0.3. So we get 0.4 squared minus 4 pi squared over 25 times 0.3 squared, and we're just going to have to calculate that. 0.4 squared minus 4 pi squared over 25 times 0.3 squared. I make it, well, I make v squared 0.01788. So I make v equals 0.134 meters per second. Nothing too crazy, and you would hope that that boat isn't going super duper duper fast. Right, now the shortest time to get from A to B, well, we basically need to find the time for both of them, right? So at point A, we get 0.3 is 0.4 cos 2 pi over 5t. Am I in radians? Yes, shift cos of 0.3 over 0.4. So I get 0.7227 is 2 pi over 5t. And that gives me a time of 0.575, and I'm going to store that as A, funnily enough. And let's do all of that with B again. So B is at minus 0.25. So what we need to do for B is the same thing, right? Minus 0.25 is 0.4 cos. Oh, we might be getting a bit of glare there. Yeah. Okay. I get 2.246 is 2 pi 5 over 2. So I get T is 1.787. So the time to get between them, store that as B, is going to be B minus A. .212 seconds. And there we have it. You go there, calculator. All right. Importantly here is being able to use this relationship so that we don't muck about. We could have just found T at A, differentiate it, plugged it in, but this is a little bit cooler. If you enjoyed this video, please, as always, like the video, subscribe to the channel, and hit the little bell notification down there so that you don't miss the next one of these when it comes out incessantly soon. I will see you soon. And from here at Nick Does Maths, all I can say is, until next time.